Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Okay, this is the questions from May-June 2010, variant 63, question 1. A bottle of sweet contains 13 red, 13 blue, 13 green, and 13 yellow. 7 sweets are selected at random. Find the probability that exactly 3 of them are red. So in order to find the probability that exactly 3 red out of 7 sweets, all right, what can we do? So finding probability, first we determine the denominator, the total number of ways you can select 7 sweets out of total 52 of them, right? Yeah, 52 sweets inside a bottle. Randomly select 7 sweets. 52C7. All right. So these are the total ways you have to select any 7 sweets out of 52 sweets. That will be the total number of ways. So in order to find out the probability, the numerator, we have to determine the number of ways we have to select 3 red sweets. And that means out of 7 sweets, 3 must be red. And then 4 can be other color. All right. Since the questions emphasize that we must have 3 red. So that means the other 4 sweets, it can be, well, this one, second one, supposed to be green, a blue, red and blue. So it can be blue, it can be green, or it can be yellow. It doesn't matter. Important, out of 7 sweets, there must be 3 red and 4 other colors. All right. So what can we do? Find out the number of ways for these selections. We have 13 red. We randomly select 3. And the number of ways is given by 13C3. And at the same time, multiply from the blue, green, and yellow. We have 39 sweets altogether. And we need to randomly select 4 sweets. Right? Then the number of ways given 39C4. And hence, we find out the number of ways we need to have 7 sweets selected that contain exactly 3 red. And divided by the total of ways without restrictions, we have the probability. All right, then we just press calculator. 13C3 times 39C4 divided by 52C7. The probability is 0.1758 and hence 0.176. All right, so this is the questions. The way the information given, we can make use of nCr method to determine the number of ways, which is the number of outcomes for that particular event and the total number of outcomes without any restrictions. And we get the probability at the end. All right, now we look at the next questions. Okay, this is the questions from May, June 2013, variant 63, question 2. The 12 houses on one side of a street are numbered with even numbers starting at 2 and going up to 24. A free newspaper is delivered on Monday to 3 different houses chosen at random from these 12. Find the probability that at least 2 of these newspapers are delivered to houses with numbers greater than 14. Okay, so in order to understand the questions, I will list down the houses with numbers starting at 2 and going up to 24. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 12 houses, right? Yeah, 12 houses. So what do we want? We want at least 2 of these newspapers are delivered to houses with numbers greater than 14. Greater than 14 is here. So number greater than 14, we have altogether 5 houses. Right? Those less than and equals to 14, there will be 7 houses. 7 houses. Okay, now we are trying to find the probability with at least 2 of these newspapers. So since the question say at least 2, and then 3 newspapers are delivered to 3 different houses. So we have to consider the probability at least 2 are delivered to house number greater than 14. So we have to consider, let's say we consider the denominator. What is the total way you have to deliver 3 newspapers to 3 different houses? There are 12 houses here, and we simply select any 3 of them, correct? That means we have the number of ways of 12C3. So this is the number of ways without any restrictions, and which is the total possible outcomes. And to get to the particular event here, at least 2 are delivered to house number greater than 14. So which means we must consider that case 1, 2 to house greater than 14, and 1 is less than equals to 14. So that's why there are 5 houses, the number are greater than 14. So out of 5 houses, we randomly select 2 houses and we deliver the newspaper. And the number of ways, 5C2 ways. All right. And at the same time, for those houses numbered less than 14, less than or equals to 14, there are 7 of them, and randomly select 1. And the number of ways given by 7C1. So total number of ways for this 5C2 multiplied with 7C1. And case 2, we have all 3 newspapers delivered to the house number greater than 14. So that's why the question used the word at least. All right, so now we consider all 3. are delivered to house number greater than 14. So there are 5 houses, the number are greater than 14, and we randomly select 3 of them, 5C3 ways to deliver the newspaper. All right, so that will be the number of ways that we want for numerator. So which is 5C2 multiplied 7C1. That will be the case 1, or plus with the case 2, 5C3. See, we can answer this question by using the nCr method, and then we will be able to get the probability. So the answer is 4/11. All right, then we have found the probability for this particular question 3 here. Okay, let's have a look at the next questions. So as you can see, this is the questions about two-way table, and we are going to find out the probability. And you can see the keyword given here. So this is a conditional probability from October, November 2013, right? Variant 6.1, question 2. So please try to answer these questions and put your answers in the comment down below. Please subscribe to the channel and like this video. I will see you in the next video. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.